Okay, today's lesson is 96. It's geometric measures with radicals. What's our objective? Get ready?
Geometric measures with radicals.
Okay. We're going to learn how to measure triangles and squares, look at the perimeter and area, when their measurements aren't like 10 centimeters, but instead they're √2 centimeters or √3 units. We're going to learn how to add and multiply in the context of geometry. So if I were going to find the perimeter of the square, I would take side plus side plus side plus side, or √2 plus √2 plus √2, and then I've got 1, 2, 3, 4 √2s, and I write 4 √2. What do I write? Get ready?
4 √2.
4 √2, so that's my perimeter. My area is going to be length times width. So √2 times √2. And we learned before that I can separate radicals, but I can also join them back together. So I can call that √2 times 2, or √4, which we know to be 2. So √2 times √2 is 2. Wait a minute, if I had √7 times √7, would that be 7? Let's check it. √7 times √7 is √49. Oh, yeah, that is 7. So is √8 times √8, 8? Okay, what's √11 times √11? Think. You ready? 11. √13 times √13. √13 times √13. Think. You ready? 13. √20 times √20. Think. You ready? 20. You got the idea. Jasmine.
So is that just because like timesing itself by itself, it's squared? And we learned a bit ago that the squaredness and the
Yes,
those cancels.
The squaredness and the square rootedness cancel each other. Yes.
Precisely.
Okay, good. So let's say if I have 3 √3s, so this one and this one and this one all together, I have 3 √3s. So how many √6s do I have? Think. Get ready?
2.
2 √6s. All right, 2 √6s. So what if they're not in order? What if they're a little bit mixed around? I can still add them. I've got √3 plus √3. So I have 2 of the √3s. And here I have 2 √2s. So I just write them separate. Now, can I combine these? Because the 2 and the 2 matches. Can I combine them? Yes or no? Nod with your head. You're correct. No, I cannot combine these because the radicals don't match each other. In fact, we know that's about 1.73, and we know that one's about 1.41 or so. So I can't treat them the same, like 2x plus 2x. They're not the same. It's more like 2x plus 2y. X and y, they're different, so I can't combine them. Emma?
So what if it was like 3 minus, or the radical of 3 plus, or minus the radical of 2 plus?
Can't combine them.
So
You
would
can
it,
add and subtract,
well,
but only
like
the
going
ones
on,
that
just
match.
taking out some of the, I can't.
That's right.
words.
Write down an example problem
Okay.
and then ask me, okay, when you think of it. Okay, so √5 plus √5, I need some help. How do I combine this one? Layla. I think you said this. Is that what you said?
Yeah.
Okay, because I heard the 2 √2. So 2 √2s plus 2 √5s. Good. Okay, √3 times √3. Sorry, √2. Lauren. √6. √2 times √2. Addison. We'll keep going with it. 2. Very good. So it's like they undo each other, right? You're squaring it and the square root undoes each other. √3 times √3. Connor.
It would be 3.
3. Very good. Okay, I got a few more for you. Whoop. How about the one at the top right here? 2 √3 times, okay, now this is important. Is it times? 2 √3 times 2 √2. Now, because I'm timesing, it doesn't matter if they're like terms. I can commute with multiplication. I can change the order and not change the answer. So I can say 2 times 2 times root 3 times root 2. 2 times 2 gives me 4. What does this give me? Jasmine?
Root 6.
Root 6. And it doesn't simplify anymore. There's no perfect squares in that one, so I can just leave it. I don't know why I'm getting all of these notifications. I don't like it. Something's turned on. It's notifying. I turned that off. All right. Yes, Emma.
I got an example.
Okay, what do you got?
So the root 3 minus root 2 minus root 3 plus root 2.
Oh, I like that. In fact, I started looking at a worksheet for you guys like that. So I've got one of these, and I'm going to subtract one of these. So these two cancel each other out. I have a negative root 2 plus a root 2. So I have one of those and one of those. They're going to cancel each other out. So in all, it's 0. Okay, great question. Yes, Hannah.
The 2 root 2 plus 2 root 5, couldn't you simplify that?
That's another good question. You guys have good questions today. Can I simplify that because the 2's match and call it like 4 root what? That's the thing, is root 2 and root 5. This is like my x, and root 5 is like my y. They're different values, so I can't combine them. Okay, that's a good question. All right, so now we're going to do some graphical measuring. So let's graph these points. 0, 4, 2, 6, 5, 3, 3, 1, and this is super cool because we haven't done one of these twisted rectangles yet till now. The question is, find the perimeter and area of this. But so far up to this point, we've taken rectangles that were all like parallel and perpendicular. We just counted units. We go, oh, that's 1, 2, 3, 4 units across. But if I turn it, that's not a unit. This is a unit, but that goes corner to corner. From here to here, that's a little bit more than 1 unit. But how long is it? How long? Because I need to figure out, I've got that one, and that one, and that one, which is all the same, right? But it's a little bit more than 1 unit. All right. We are back going. Okay, so our dilemma was trying to figure out how long this is. It's not 1 unit. This is 1 unit, and this is 1 unit, and that happens to be a right angle. I'm hoping you guys are seeing this. Your brains are thinking, they're calculating. Lexi.
So I thought that if you just found the regular area, since both sides are half, then wouldn't it just cancel each other out because you wouldn't have to divide? Because every single side has half of the square. Half the unit, so you could just
count this whole square.
Yeah,
But then
just
cut
count
that
the whole
square in half.
because the bottom part of the square also
1,
has
2,
half.
3, 4, 5, 6, 7 full units. That's a full unit. That makes 8, 9, 10, 11, 12. Let's test her theory. So we're thinking 12 units squared for the area. Let's check it, because we also still have to find perimeter. Okay. So perimeter, we got to know this length. That's our questions. How long is this thing? Well, we're still stuck here. How long is this diagonal piece? It's a right triangle. Both legs are 1. It's a hypotenuse. It's isosceles. Colin? How do you know it's root 2?
Because I did math.
You did the math. There's 2 ways to do the math. Who sees it? Samantha?
It's a 45,
45, 90. The pattern is x, x, x root 2. What's my pattern for a 45, 45, 90? Get ready?
X root 2.
Perfect. So you can memorize that. If you didn't memorize it, the second math way to do it is to go 1 squared plus 1 squared equals c squared. That's our unknown. 1 plus 1 equals c squared. Combine them, that's 2 equals c squared. Root both sides. Root 2 equals c. Perfect. Okay, so that's root 2. This is root 2. Root 2, root 2, root 2, root 2, root 2, root 2, and root 2. How many root 2's, if I'm walking along and measuring the perimeter, I'm going to come across how many root 2's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 root 2's for perimeter. Units. Let's check area. Area is length times width. Okay? So what is the length from here to here, measuring it by root 2. Okay, Hannah? 2 root 2. I have 2 root 2s. What is my length here? How many root 2s do I have? Michelle?
3.
I have 3 root 2s. So length times width is my area. So area equals length times width is going to be 3 root 2 times 2 root 2. Solve this on your papers. Put your pencil up when you've got it. You have 15 seconds. Okay, what did you get, Gage? You did it mentally. What did you get?
12.
How'd you get 12?
Because the 2 roots equal 2, and you multiply 3 by 2, and then multiply that by 2, you just multiply.
Okay, so 3 times 2 is 6. Root 2 times root 2 is 2. Perfect. Awesome. See, that one was a good mental one to do. I think we've got one more to do. Oh, and by the way, did it match? Here's our 2 areas. We did it by counting like half of a triangle method, counting the grids, and then we also did it that way. Quick question. Let me back that up because there's a practice set one that kind of tripped up some of my other classes. Let's say it was right here-ish. Okay, we said from corner to corner was root 2, but what if you had this corner to this corner? Is that also root 2? Well, how? We said corner to corner is root 2, so how am I supposed to know what this to this is? Can I build a right triangle and go, oh, okay, that's 1 unit, that's 2 units, and use Pythagorean's theorem? You already know it, Lexi?
No, I just had a question.
Okay.
I don't understand how you got 12.
From right here?
Yeah.
So we did, it's all timesing. So picture if you rearranged it and went 3 times 2 times root 2 times root 2. This gives you your 6, and then root 2 times root 2 is 2. Okay, great question, Hannah.
Can you just flip the rectangle?
You could flip it, but you have to see that this is not the same length as this. It'd be like this. And so, I mean, I could take a yardstick and go, oh, it's maybe about, but it's going to be more than 1, 2, 3 units. It's going to be maybe like somewhere in here, but how far? This one's a 30, 60, 90. Here's your 60, here's your 30, because it's 1. You guys just remember this. This you forgot, that's okay. You can go 1 squared plus root 3 squared equals c squared. Gage?
So you could also, on the graph, people could use that in real life if you're talking about something that you can't like physically go and see, like space.
Yeah, great idea. You can plot it out on paper so that you can see where's the angles, where's the dimensions and the hypotenuse. Okay, good application. We get 1 plus these cancel. We get 3 equals c squared. 4 equals c squared. Square root both sides. So we get 2 equals c. There's our 2. And now, yes, that confirms it's a 30, 60, 90. Can we find the perimeter? Now, a lot of students miss this on the practice set, so stay with me. Perimeter is the sum of all of the measurements of the sides. So if I'm going to add those up, I'm going to say root 3 plus 1 plus 2. Did I do any multiplication? Is there anything being multiplied in here? No. But I can add 1 plus 2. That's a tough one. Okay, it's plus 3. Is it times 3?
No.
No, it's plus 3. I had like tons of kids saying times 3. They kept giving me this. Like all day today I've been seeing this. It is not multiplied. So add plus, plus, plus. Add them together. Area. You need to know area is 1/2 base times height. 1/2 base times height. What's the area of a triangle, class? Get ready?
1/2 base times height.
1/2 base times height. Let's use for my base, root 3. My height is 1. Ooh, how do I combine that? They're multiplied now. You can't really do anything with them. 1 doesn't even matter, so I can take that away. And you can't really take half of root 3, so we just write it in its most simple way. And we say root 3 over 2. And we're in, it doesn't say, so we're in units squared. Any questions? Annika?
It looks like for area you will
Area. Connor?
What if you're trying to find like the area of half of the triangle?
You could just take that and cut that in half, so it'd be root 3 over 4. Okay, Lexi?
So when you have like right there, root 3 to the second power, is that always going to be 3 over on the other side? Or is that only when it can be 3? Or is when it's 2 root 3? Because it's 2.
Oh, are you talking about for the 30, 60, 90, then multiple?
No, just for when it's like has to the second power.
Okay, so any root at all, root 17 squared, it will always be itself, because these are inverses of each other. They undo each other. Okay, good question. All right, that's it for today. So take a stand-up break. We're on 6:42.